Hi everyone, I'm Kota. I'm gonna talk about SAT 315 task MS3 to T2C. And this task is to need to demonstrate the skills to use MPI and OpenCL. I choose data sort algorithm quick sort. This This is quick source MPI source. This is variable random array function, swapping function, and this is rearranging array using the partition. Start from the rightmost element as pivot. We can also select leftmost or randomly smaller element index. If current is smaller than or equal to pivot, we swap. Swapping with greater element at I. This is quick sort function. For first iteration, it will be checking if the last element is greater than the first, then swap and so on. We find the pivot. Call on the left or pivot to sort. Call on the right or pivot to sort. This is quick sort API. Normal sequential quick sort. And this is the main part. This is variable initializing the API environment. This is to get the number of tasks process. This gets the rank and find the processor name. If rank equals 0, execute random array function, and this is to start clock and then execute quick sort MP and stopping the clock and calculate the execute time and output execute time. Next, quick sort C OpenCL source. This is variable declare each of the functions before use. Its main part to start clock variable instead of the MPI environment. The head and the node have different functions. The head kicks off the internal kick sort implementation. If process rank equal head, head is 0. Execute head function, else node function. This is the head function and to start the clock, initialize and allocate the memory for array. Start by calling in initial call of quicksort everywhere on the main process, and to stop clock and to calculate execute time and output execute time. This is not a function, not how to get a partition size, the parent and the data sent to them declared here. To get the depth of process first appears in using a left shift of 1 from the current divs. Divs will increase by 1 every 2, 4, 8, 16 total rank, indicating the divs. Probe for a message before correction is so we know its size. Get the size and parent of the message. Locate space for the section of already node get. Receive the data from the node into array part. Start a quicksort MPI. Resource call on this node. Once the quicksort has finished, return the array part to its parent. Function for creating and initialize the array. And this function is swap. Partition function that takes minimum max puts all less than min to the left of or item, greater than item the left is. Then the current point of pivot so the recursive quicksort call round each side of it. Run a partition function run by the quicksort algorithm takes a random item from the array and swaps it to the end to be partitioned. This is done because normal quicksort has an expected has runtime of we saw randomize has an expected runtime and log n much faster. Recursive quicksort function takes an array onto endpoints. This is recursive, so can be the each of end of the array or just a small section with it. If the provided mean is still lower than the provided max performance, the quicksort is because at the tips of each branch we will reach a point where we only have one value. Partition the array with everything greater than split on the right of it and everything less of left. Run the recursive quicksort algorithm of each partition of the array. Ambient version of the quicksort algorithm is in the account which node data needs to split into. When a node runs this, it checks if the indicated child exists in the set of more nodes than if it doesn't. It just runs a normal quicksort If it doesn't exist, partitioning it down and one half is sent to the child while the current node works on the other half. You get the rank of child using the current process rank. If the children doesn't exist, normal quicksort. This is quicksort CA files. Start from rightmost element as for which we can also select left or randomly. Swapping with greater element.I, kernel void. Next I run the file. In this time we use MPI, so firstly we need to write API CXX, and this part is output file name, setting output file name. Oh, yeah, sorry, I mistake. Success. Next, OpenCL. We need to use MPI-6, and then when we use OpenCL, we have to add -l OpenCL, and this part is to set output file. I finished. Thank you everyone.